In this video, we're going to look at question 4 from the tutorial sheet, looking at questions where we describe what's happening. We're given a scenario here where a pneumatic system has been used to lower metal components into an acid bath, and we're given a prompt at the start of this question. We're asked to describe the operation of the pneumatic circuit when valve 1 is actuated. So what we're saying is we're told this actuation, this being switched on, is going to be our starting point. Before we get into describing it, it's worth having a look at what's currently going on in the circuit before we do anything. Where we have main air supplied, we have main air supplied into valve 1, which before it gets actuated has nowhere to go, so it's currently not travelling. And we also have main air supplied, as we would always have, to the 5-2 valve, and currently it's in the state that we find at the beginning, and we have air flowing through the valve and through this unidirectional restrictor. If we pay careful attention, we'll see this is the direction in which the air is not restricted, so it can flow this way and flow that way. So when we have air flowing in this direction, there's no restriction. And currently, before we do anything, the air will be holding the piston in place. So our piston is currently in-stroked, nothing's happening. It's kind of a standard starting point for a question like this. This is what the air is doing before anything happens in the circuit. So we're going to anticipate that our action is going to be causing the piston to outstroke in some way, but we have to put this in the correct words. So I'll take this away just now, but just so we know where we start with to begin. So let's focus on valve 1. So valve 1, we do have our main air ready to be passed through. And when valve 1 is actuated, what's going to happen is that our state will change. So if you imagine our box sliding over, so this box slides to the left, you imagine, it's going to allow air to flow through. So we just draw an arrow through, but because the box has slid over, and we've got air now waiting at valve 2. We should recognize this as an AND control, 2 3-2 valves in series back to back like this. Both must be actuated in order for air to progress. The first thing we want to say is when valve 1 is actuated and valve 2 is actuated, because what we're saying here is that without valve 2, nothing's going to happen. Well, valve 1 and valve 2 are actuated, then pilot air is supplied to valve 3. So we don't need a big burst of air, we just need valves 1 and 2 to be actuated at the same time, and that's going to allow, it could be a burst, a short puff of air, it's going to allow air to be supplied as pilot air. Remember, pilot air is the air that's used to actuate valves. It's not going to be going into a cylinder, it's not going to be used to move a piston. This air that's coming through valve 1 and valve 2 is just being used to switch the state of valve 3. Now we've seen before anything happened, valve 3 was in this state here. This is the state we were in, meaning that the air was being supplied through this side. When valve 3 is actuated, we're going to switch state, and that means that this whole set of ports will be switched across that way. So instead of our air coming out on the right, it's going to come out on the left. So we've got air coming down this way, and it's going to reach this T section straight away. Now, if we look to the right, going along this path, we can see there's a restrictor there, and this is the direction of restriction. So if air comes along, it's not going to get past this ball on the cup there. So air will be going slowly to the right. Air will always take the path of least resistance first. So it's easier for the air to continue down the T section. And some air will probably start to go down this way, but until the resistance is higher, pushing the piston out, it's going to come down this way first. We're going to come down this way, come in the top end of our piston here, and of course we know what happens when we supply air at this end of the piston, it's going to cause the piston to outstroke. So our piston will now move to this position out here. Our piston will outstroke. Once the piston is fully outstroked, though, that's when there'll be no further capacity for air to travel down the way. But let's write up what happens first of all. Let's deal with the piston. So we can say first of all, valve 3 changes state. That's our 5-2 valve. We talk about that switching over. Air is supplied top. Piston. Once the piston's outstroked, air is going to be continued to be supplied down this line, so nothing's going to change here. We're going to continue to have air being supplied here because we've not got anything to switch the 5-2 valve over. When air can't flow any further down towards the piston, then the only path that air has is to flow to the right here. So I'll rub this out just now. The piston's still outstroked. We've still got compressed air. Let's push this down here. But now air is going to flow this way because this is the path that air can now flow. No more air can flow into the piston. This whole cylinder is full of air. There's nowhere else to go. So air is going to flow down this other junction of the T section over here. And it's going to flow into the component 5, which is the unidirectional restrictor. It's going to come through slowly. So the air, when it passes through this point, because it is in a restricted path, it's not coming as quickly or with high pressure, which means it cannot yet send pilot air signal around. There's not enough air pressure to do so. So the reservoir needs to fill up first. So we need to have this reservoir fill up with air. And once this is full, the pressure will be high enough and we can send a signal back around here. So we can write that up first. This is going to create a time delay. So there'll be a pause while this happens. I'll write this up and then I'll go back and say one little thing that I should have mentioned before. So once the cylinder, once the piston is outstroked, air will flow through the restrictor 5 and full reservoir. Now, one thing I neglected to mention, I should have said, is as the piston is outstroking, this is in a previous step here, so back here, as the piston is outstroking, this is this step here, it's outstroking slowly. Now, why is this the case? So let's take a step back. Because as the air is exhausted through here, it's now going in this direction through restrictor 4, which means that it can only flow through this path. It cannot go past the ball in this direction. So something to watch out for, and definitely worth a mark in a question like this, is to say that it outstrokes slowly. So just one word I missed out there, but it's something that's definitely worth including for full marks in a question. Outstroke slowly. And we can elaborate, we could say due to unidirectional restrictor 4, but actually just mentioning it slowly means you've recognized what that component's doing and you've correctly identified it. So apologies for jumping back slightly there. But anyway, once the piston is fully outstroked, and it's outstroked slowly because the air exhausting from it has to go through restrictor 4, then air is going to fill up the reservoir over here. So we've got this bit going on over here that's circled in green. Once that's full, once the reservoir is full, then pilot air can be sent back to the 5-2 valve. So the reservoir is full. Now, of course, it's been supplied to valve 3 from the other side. It's been supplied to valve 3 here. So what this is going to do is going to switch. It's going to switch valve 3 back to its original state, which means air will now be supplied to the bottom of the cylinder, and it's going to cause the piston to instroke. So exactly where we started. So I'll just erase some of the drawings from the diagram just now, just so we can see what's going on here. If we have pilot air coming in here, going to switch us back into this state, meaning air is going to flow up this way again, and our piston, which is currently outstroked, is going to have compressed air pushing it back in stroking the piston. So let's write this up to conclude our question. Actuates valve 3, causing it to change state, supply air to the bottom of the cylinder, causing the stroke. Let's take it from the top. Let's summarize what's happening in our full scenario here. So at the start of our question, valve 1 is actuated, but until valve 2 is actuated, nothing happens. So valve 1 and 2 have to be actuated, and this is what allows the supply of pilot air to valve 3. So once valve 1 and 2 are both switched on, because and control, we're going to get pilot air coming around here. Once we've got pilot air, this is going to cause valve 2, but valve 3 rather, to switch, meaning the air can now flow up this way. It won't flow this way yet. It's not going to flow to the right yet because of the restrictor in place. It's going to go the path of least resistance and come up to this cylinder here, cause this piston to outstroke. And it will outstroke slowly because as air exits, it's getting slowed down through valve 4. So full speed air is coming in the bottom of the piston, but it can only outstroke slowly because the air that's currently inside it is slowed down through valve 4. And the piston will continue to fully outstroke until it's all the way out. Once the piston's outstroked, so once we've had all this air coming down here, then no more air can travel down. And so the only path air has left to flow is through the slower route I wanted to avoid before, to go through this way. So it is slowed coming through here. So here it's slowed down here, but it's the only place our compressed air has to go. And as it comes out, there's not enough pressure to continue around like this straight away. We can't continue around and send the pilot air to valve 3 yet. So what has to happen is the air comes through and it fills up the reservoir. And this is where we'll have a time delay. We're going to wait while it's filling up. And once it's full, then that means there's high enough pressure, and that will send the pilot signal round here. So once again, valve 3 actuated, it's switched back to the way it began with. And this means that at this point, we can resupply air this way. It's going to flow up. There's no restriction in this direction. It can flow through both parts of the restrictor because it only restricted going up the way, if you like, in this diagram. It flows along here. Our piston, which is currently outstroked, will now be instroked by air being supplied at the bottom. And that will be where everything stops in this circuit, because this is a semi-automatic circuit, meaning until we actuate valves 1 and 2 together again, nothing else is going to happen. So the piston will remain instroked until it all starts again. But giving an answer like I've typed up on the screen here would be enough to get full marks in a question like this.